In this video, we are going to demonstrate the lane detection system on three test cases. The first test case is a video for a straight road, and the second test case is a video where the road turns. Both these videos are from publicly available Udacity dataset. And the third video is a video that we shot on our own, and this in fact is the most challenging video. So our implementation works in two modes. The first mode is where it just uses computer vision algorithms to detect lanes. The second is where it also has some high-level logical information such as how the road turns, that road the lane can fork into two lanes, and does some frame-to-frame filtering to be able to make the lane detection more stable. So starting with a simple video of a state road and the plain naive implementation that we have without these high level logical information of frame to frame filtering. On the top what you have is the actual video. In the middle you have the output from the computer vision algorithm. Um, in particular we're using Hough transform to detect edges. So these are the edges that are detected, and you can see here that there are no videos, there are no traffic, and the edges are very clearly marked. So these two red lines which correspond to the detected lanes, they're able to track the actual lane pretty accurately. Moving to a slightly more interesting example of a road which turns, and starting with the simple implementation. Here what you will see is that there are shadows on the road, and because of that we get on some frames the lanes are not very clearly visible, because of which the lane detection engine will end up um, misdirecting the lanes. And you can also see that the lanes are not very stable frame to frame, as we see shadows, or because of the turn-in the lanes get mispredicted. And that kind of motivated us into looking into improving this lane detection through adding high level descriptions as well as doing frame to frame filtering. And here you can see that even when we are hitting the shadow areas, the lane detection works reasonably well. We deviate from the actual lane, but pretty soon we recover, but we don't have the same kind of fluctuation that you were observing earlier. Now moving on to the third video, which was definitely the most challenging of all. We start with a simple implementation. Again, these red lines represent where the lane detection engine thinks the lanes are, and here you can see that the right lane is almost not visible, and we are doing the standard tricks of computer vision to define region of interest, and then also provide some information about some angle zone in which the lane can lie. But still, because the lanes are not very clearly marked and because of the traffic, often what we observe is that our system will end up misidentifying the lanes by picking a line which has a similar slope as what it expects from a lane, but which actually corresponds to something completely different from the lane. It could be traffic, it could be the end of the road. So in this particular video, we found the naive implementation to be performing quite poorly, and now if you use the implementation where we have some frame-to-frame filtering, and here you can observe that we start with again some initial guess about the lane. It takes a while because of filtering to eventually converge to the correct lane, but once it does, it will stick to that uh, representation even when lanes are not clearly visible. Particularly the left lane, it is able to converge very well because on some frames it sees a clear line here which reinforces its expectation of seeing the lane there. On the right as well, um, we have a reasonably good direction of the lane. And very soon we will see that this particular lane will fork into two lanes, one which will turn left, and this implementation handles that fork in the lane better than what the previous implementation did. So it moved. We had the lane detection expected the lane to turn right, but then it quickly realized that it was a fork and came back, and you can see that it is accurately predicting the lanes now. So this is a work in progress, and we are continuing to improve it.